For our first session tonight, I'd like to introduce former NASA astronaut Garrett Reisman to talk about his personal connection to SciComm. Originally from New Jersey, Dr. Reisman obtained advanced degrees in mechanical engineering from Caltech before being selected as a NASA mission specialist in 1998. Garrett has flown aboard the space shuttles Endeavour, Discovery, Atlantis, and spent over 107 days in space aboard and also just outside the International Space Station. Since returning to Earth, Garrett has held senior positions at SpaceX and is now Professor of Astronautical Engineering at the University of South California. Garrett, thank you so much for being here tonight.
My pleasure. It's great to be with all of you all over the world. It's really cool.
One of the most incredibly important parts about science communication is the idea of communicating not only the science itself, but the ideas behind it, the ideas of critical thinking, of how we interpret information. Now, Garrett, I'm sure that you've noticed in recent times as well, we've been seeing this creeping into our everyday lives and into political life. I mean, there are some conspiracies that might appear as being somewhat harmless, but what do you think are some of the more troubling aspects of the spread of misinformation and the lack of science communication?
Yeah, it's definitely getting more and more alarming. I remember it's always been with us. I mean, conspiracy theorists are nothing new. It goes back centuries. But when I first became an astronaut in the early days, it was mostly centered around people who thought that the moon landing was a hoax, and that we never actually went to the moon, and it was all on a soundstage in Hollywood. Ironically, by the way, it's really funny. I'm working on a TV show now called For All Mankind. It's on Apple TV, and where we have a soundstage in Hollywood where we fake moon landings. And I can tell you, it's really hard. And I'm the technical advisor, so it's my job to try to get it as realistic as we can. And we still mess it up all the time. And I keep telling the producers on the show that I will be very happy when people notice that we did something wrong. I hope that we make some egregious mistake, that we have something that's completely technically incorrect, and that people notice it. And by the way, that has happened. And I could say, so that I could just, I said, I'm all ready with the tweet. I'm going to say, see, even in 2021, we still, with all of our fancy visual effects that we have now and all of our computer technology and green screens and everything we have, we still can't fake a moon landing, So I used to find it kind of humorous, these people that thought that it was all a hoax and that it was fake. I was like, oh, isn't that kind of cute? And I used to almost take it as a compliment, because it told me that that what we did back in 1968 when we, 69, when we landed 2 men on the moon was so difficult to digest and so hard to believe that people are still having a hard time wrapping their head around this technological feat that was, borderline miraculous.
I mean, it is pretty unbelievable. Yeah.
Yeah.
Do you think maybe, sorry.
Yeah, but the problem is now, so I used to take it, I also almost take it as a compliment, but the problem is now it's really gotten out of control, where so many different conspiracy theories now in space exploration field. It's, there's conspiracy theories that people think the Earth is flat, and that NASA is completely a government conspiracy, and that we didn't do any of these things. And the problem is it's even creeping over and it's becoming very prevalent in our political domain, because, and this is also not necessarily a new thing, but a lot of our political leaders are realizing that they can derive a lot of power and control over the population and political power by convincing people that their opinion is fact when it's not. And this is a very corrosive and dangerous thing. I mean, the big lie that politicians use to control and do terrible things. I mean, it's what Hitler did, is what Stalin did. This is not a new thing, but it's becoming more and more prevalent in democracies, and that is a scary thing. So I no longer think it's cute.
I think the points that you're raising are incredibly prevalent, especially nowadays. Do you think, though, that there are certain things that you've been able to do in your career at NASA, or NASA in general? Maybe there's been a switch in the mindset to kind of make these unbelievable things that are kind of disconnected from people's everyday lives more accessible, more humanized?
Yeah, and so that is a good thing. So I think that we have done a better job of reaching out to a large segment of the population and communicating in less than esoteric terms, being able to communicate to a lay audience what we're doing and why it's important, and that's great, and we're getting much more savvy about it, and part of it I think started in at least in the space business. Part of it was started at SpaceX with the webcasts we were doing, were very entertaining and focused on communicating. Don't use acronyms. Don't let terminology be an obstacle to communicating the basic facts. And NASA has gotten much better at it too. If you look at NASA broadcasts, they're much more entertaining than they used to be, and that's a good thing. But along the way, we have to make sure that we don't dumb down the science and the fact, and that we still communicate the most important essence of what we're doing, and the scientific investigation that's its foundation.
So it's a good thing that you bring up the scientific essence, because I wanted to talk to you a little bit about the way that you mentioned that you consult on For All Mankind on a sci-fi show that describes this kind of future that we didn't really experience exactly, with humans living full-time on the moon. Tell me, what do you think is the importance of the relationship between science and science fiction? How accurate do things need to be? What are the real benefits from science fiction?
Well, it really, the benefit of science fiction is in its ability to inspire and imagine a future that we can then go off and create. Because before, you could just go ahead and develop a new technology or a new tool. Somebody first has to imagine it, what it looks like, what it could do. So there is this creative element that is necessary before we do anything that's truly innovative in the world of engineering and technology development. So a lot of times that innovative spark comes from fiction, and whether that be Jules Verne, who thought that we can launch people into space from Florida, that would be a good place to do it. He put that in a novel way before anybody started breaking ground at Cape Canaveral, right? So somebody, and another great example is 2001: A Space Odyssey, where Kubrick put in there astronauts using this crazy tablet that they would be able to touch, and it was like a computer screen that was mobile, and you could hold it like a book, and that ended up, now we have iPads, and so a lot of times the things that you see in fiction, and whether that be in literature and in movies, eventually end up being the inspiration for the engineers to actually make it real and actually turn it into real things. So and vice versa, because the person that was the creator of this show, For All Mankind, he also created Battlestar Galactica, the new reboot that you might have watched that series. And he came to my launch on the space shuttle, and he talked about how he felt like he was coming full circle, because he was originally inspired to do the fiction and the work on Star Trek that he worked on before Battlestar Galactica, because he was inspired by what he saw in the Apollo program. And so science exploration fact inspired him to create better fiction, and then the fiction inspired us to do better jobs. So there's definitely an interplay there, which is very interesting.
I think you're 100% right, and that interplay between science fiction and actual science and the way that it influences society is incredibly important. But to get to that point, to get to the point where you have scientists who are willing to consult on films and TV shows, you need to have science communicators. So what do you see as the most critical way that we can use social media better as science communicators?
I think one of the most important messages to get out there, and I think, again, going back to this this kind of cancer that we have in our society of the conspiracy theories and so forth, I think one of the most important things we can do is explain the difference between opinion and fact, because that is a line that is getting blurred, and the difference between something that is supported by evidence and by empirical data and something that's just an opinion, and why there's a difference. So I was in a meeting once, and there was a bunch of people in there, and one of them was one of these flat Earth guys, and was trying to tell me, and I was explaining that no, I went up there and I went around, we orbited around the Earth. I looked out the window, it is indeed round. And he said, we're just going to have to agree to disagree. And I said, no, you don't get to disagree. You can't disagree about a fact. We can have different opinions. We can disagree about whether or not broccoli tastes good. Okay. We can disagree about that. You can have an opinion that broccoli is delicious. I can have an opinion that it tastes terrible, and that's fine. Okay, but you can't have an opinion about whether or not the nature, the truth of the universe and how it works. And the most important thing we can explain is that the reason that there's this important difference between opinion and fact is not only is it important for truth, but the thing is that facts are useful. Okay. If you come up to me and say that my opinion that the world is flat is just as valid as your opinion that it's round, I have to say, okay, well, show me the mathematical constructs, the equations, the models that allow you to take this flat Earth opinion and do something useful with it. The fact that the Earth is round and we have a whole theory of gravitation, we have a whole calculus behind it, enables us to predict the motions of the planets. It enables us to put up satellites that provide GPS and allow us to navigate our airplanes and allow you to find your way to the falafel store or whatever. So there are useful things that come out of correct factual scientific theory. You can then use it to predict the future and to create things and to send probes to other planets. So I say, okay, if you think the Earth is flat, show me the mathematics that support that would allow me to send humans to the moon. Show me that. You can't, because all you have is an opinion. You don't have a fact. All right. So that's the difference. And I think we need to do a better job of explaining why that's important.
Garrett Reisman, thank you so much. You're 100% right. People need to understand the difference between a theory scientifically and a theory in a colloquial sense. I wish we had more time to talk about this, but we're very limited on time tonight. Thank you again so much for joining us, and I hope you'll agree to come back for next year's conference.
I'd be happy to do that. It was really nice talking to you. Thank you.
Same here. Thank you very much.